Well, I think I'm going to make some more philosophical approach to this problem. Well, I think that the origins of the neutral theory constitute a very interesting subject because of different questions, because of the obvious importance of the theory, because it allows us to inquire into these fascinating lives. I love to hear about Moto Kimura and about Tomoko Ota, etc. Of course, it illustrates how molecular biology has permeated all biological fields, and this is a very important historiographical problem in the history of biology. So I think, for instance, this is the view that Michael has adopted in his '94 paper, but it's also a very large question for historians of biology like Lily Kay. And also because I love to do history of recent science, and I'm going to tell you why. But it is also for more very interesting subject for more philosophical or general questions about the nature of science. And I mean by that, for instance, of course, it is at the center of one of the major controversies in contemporary biology. Of course, it is fading away, and it is an excellent example of the role of theories in discipline building, and this was the main objective of my paper in 1906. And it is a wonderful case in arguing for the epistemic diversity of science, which is also a point that I want to make in my view of the neutral theory. And of course, I want to say a few words at the end of my talk about the role scientists play in the historical reconstruction of science. And because we're talking about the history of recent science, this is a very important issue for historians and philosophers of science. So I think, as we have seen by the previous speakers, the history of the neutral theory has been told from basically two perspectives. One, which is of course illustrated by Richard Ev14 book, is one that emphasizes the relations of the neutral theory with developments in population genetics. I saw this problem to be linked, as Richard just told us, with the problem of intrapopulation variation. And of course, in this version, the role played by Kimura is emphasized. And this is the only picture I could find in the internet of Lawrentians. So I think we need a more recent one to be circulated. Yeah. Okay. And in this version, we need well. In this version, of course, King and Jung's version practically disappears. The other version puts its emphasis on the different versions of the neutral theory, of its diverse origins. And of course, this is the historical approach taken by Michael Dietrich and by me. And well, you see here Linus Pauling, and in the middle it's Emil Zuckerkandl 10 years ago at Palo Alto. Of course, in this version, we have emphasized the role played by technical and conceptual developments in molecular biology. So Dietrich wrote a paper in which he presented what he called the Lewontin's historical thesis. And of course, when I wrote my paper 2 years after that, I wrote about the Dietrich historical thesis. And the Lewontin's historical thesis sustains that the primary evidence for the neutral theory were the high levels of genetic polymorphisms revealed by electrophoretic methods, and that the neutral theory is but a continuation of the classical position, as we have seen before. We try to extend Dietrich's arguments, and I wanted to make some more, as I told you before, some more general or philosophical claims about what these differences in interpretation meant for broader questions. So we recognize that certainly there was an involvement of Kimura with the classical views. This is obvious with all Kimura's education with Crow, all the problems he had been attacking, the '64 paper. There are a lot of evidences of course, this paper with Crow, in which he recognizes the theoretical, as a theoretical case, the existence of neutral mutations. But Kimura's paper was concerned with issues of evolutionary change. If you see the 68 paper, which of course, as Will Provine has just told us, the commitment of Kimura's original paper with this problem of protein evolution put Kimura into a number of problems. He had to change, after 68, many of the views and the evidence sustained at that paper. Because, for instance, in the 68 paper, the main evidence for neutral evolution was the high levels of substitution, of the high rate of evolutionary change in proteins. But King and Hughes made Kimura see that the problem was not the high levels of substitution, but the constancy rate of protein evolution. But that was, the molecular clock. So that was the problem. And the other ones was that in 68, Kimura thought that neutral mutations were the vast majority of all variation found in populations. But King and Hughes made him think that it was there was not a need that the majority of variation was neutral, but only between 10 and 15% was enough to explain neutral evolution. So Kimura actually made these mistakes, and he had to change later the evidence in favor of his theory. So in the main evidences for neutral evolution came from molecular biology, of course, from the papers included in this Rogers conference book. There were studies about sequences of globins and cytochrome C, and some unexpected phenomena recently found in molecular biology, like satellite DNA, for instance, which was the first of the repetitive sequences, which was discovered in the late 60s. So this was very new evidences coming from molecular biology. They had nothing to do with questions of population genetics. Of course, the argument that the primary structure of proteins is largely determined by the structure of the genetic code. They had, as just Dick has reminded us, a lot of arguments about the structure of the genetic code, the degeneracy of the genetic code, etc. So this last argument is very important, the structure of the genetic code, because it illustrates one of the main points in King and Hughes' paper, which is the role assigned to the fixation of mutants on DNA as the driving force. They call it the driving force of molecular evolution, because they are trying to push a version in which they are sustaining the difference between the split in the mechanisms of evolution between the organismic and the molecular level. So what they're trying to do is to break the extrapolationism, which Gould has called, of the synthesis of the synthetic theory. So I think in King and Hughes' view, random drift is a physical force. So they're trying to make this point that this is a physical force, and and DNA, it's a molecule. It is driven by random forces, and so this is the main evolutionary force at the molecular level. And this force is very different than the forces, the causal mechanisms that we see at the organismic level. So they are trying to push this very philosophical, explanatory point in their paper. So the protein molecule is continually challenged, they say, by mutational changes resulting from base substitution and other mutational events in DNA. Well, why is it important in this historical or historiographical discussion? What is the meaning of the differences in the historical interpretation of the origins of the neutral theory? What is the point of discussing if Dick Lowenstein's thesis is incomplete or incorrect, or if ours have extended the argument about the origins? I think the answer has to do with two questions. I think that they might be important for assessing the role of theories on discipline building, and if we want to argue for something that historians and sociologists of science have been arguing in the last 2 decades, which is the epistemic diversity of science. I think despite Lewontin's desires or whatever, I don't know, or commitments, explicit commitments, Lewontin's historical thesis is related to a view of science as a mostly theoretical activity, in which experiments are subordinated to the different hypotheses scientists want to test. So, in this case, of course, I am not saying that you are sustaining, for instance, some positivistic extreme version of science like Nagel, but in this version, which is mostly exemplified by Nagel's theory, scientific disciplines are mostly structured around theories. And for authors such as Nagel, the role of disciplines is to be unified through the reduction of the characteristic theories. It is very impressive when you read the literature on disciplines on a very broad set of philosophers. They just talk about disciplines when talking about the unification of science or talking about the reduction of one discipline to another. They just talk about disciplines in this way. But the big issue, I think, in the Lewontin historical thesis, so as we have seen, is the theoretical controversy between the balance and the classical school. So in this thesis, the theoretical controversy is emphasized. And as we saw, the experiments are subordinated to these theoretical needs. This type of experimentation, of this kind of traditions, can be thought or even designed before the techniques or the technology exist. So it is very clear in their 66 paper that Hobby and Lewontin, not Lewontin and Hobby paper, but Hobby's and Lewontin paper, stated very clearly which methodological conditions their experiment should meet in order to deliver data to choose between the classical or balanced hypothesis. So they have very clearly in their minds which kind of experiments, which kind of methodological constraints the experiments have to meet in order to choose between the classical and the balanced hypothesis. And I love this quotation from Lewontin's book, because I think it is a wonderful statement about what experiments meant to theoretical scientists. It's wonderful. Let me read it. For many years, population genetics was an immensely rich and powerful theory with virtually not suitable facts on which to operate. It was like a complex and exquisite machine designed to process a raw material that no one has succeeded in mining. Occasionally, some unusually clever or lucky prospector would come upon a natural outcrop of high-grade ore, and part of the machinery would be started up to prove to its bakers that it really would work. But for most part, the machine was left to the engineers, forever tinkering, forever making improvements, and anticipation of the day when it would be called upon to carry out full production. So I think it really exemplifies, it illustrates the state in which population genetics was in the 60s, in the 50s, in the 60s, but it also shows about what theoretical scientists think about experiments. They can build their theories without, of course, they would be very happy to find all these facts to fit the machinery, but they can tinker with the machine, with the theoretical machine, without having these facts.